A function is one-to-one if any two inputs in the domain correspond to two different outputs in the range. That is, if x1 and x2 are two different inputs of the function f, then f is one-to-one if f of x1 does not equal f of x2. To be able to tell if a function is one-to-one, we're going to use what's called the horizontal line test. And that says that if every horizontal line intersects the graph of the function f in at most one point, that means it can only cross the graph one time, then f is one-to-one. So we have this first graph here, and we're going to use the horizontal line test to tell, is this one-to-one? So if I draw a horizontal line, it crosses two times, right there. Technically it crosses two times at an infinite amount of places, but all I'm really looking for is that it intersects anywhere once, or anywhere more than once. So since it does intersect right here more than one time, this is not one-to-one. Now we have this function here. See it going up, and we're going to use our horizontal line test to tell if it is one-to-one. So once, 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 once. Now here is a little bit hard to see. It doesn't actually flatten out. It's just a slight increase from here to here. So while technically it looks like it crosses multiple times, it really only crosses one time. If you zoom in, you would see that it only crosses once. So we can tell that this function here passes the horizontal line test because it only crosses at most one time. So we can say that this function, write it a little bit better than that. This is 1, 2, 1. And here we have this really odd looking function. Let's see if it's one-to-one. So once, 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 1, 2, 3 times. Well, it's only once at a bunch of times up here and down here, but right here, this little odd turning point here, it crosses 3 times a bunch. So we could say that this is not one-to-one for this function.